All right, so we're getting started here. Here's actually the answers to all of them. You guys only had to do every other. So starting at the top, you had to fill in 7, 1, and 37. By the way, there's no wiggle room for these. These have to be exact. Then you had to do this one that started with 4. You had to fill in the 0, the -7, and the 42. You guys went to this 26 number, so that was 15, 11, and 28. How are we doing so far? Are we doing woohoo, everybody? Okay. Then you went to this 28. So you had to fill in 17, 11, and 9. Then you skipped to the first blank there. So you would have filled in the 18, the 15, and the 81. I believe we did this next one together. So you filled in 20, 15, and 12. With the 17, like we talked about in class, when you have to do an odd number, there are no odds numbers going down for the dry bulb. They shortened it up and only put the evens. But as hopefully you found out, if you do 16 and 18, you can get an answer. And then the number would be right in between. So when you do 16 and 18, I believe you got 8 and no, you got 9 and 11 for the dew point. So that meant for 17, it would have been 10. Same with the relative humidity, you should have got 63. Coming down here, then the next one you had to do was the 5. So you should have filled in the 3, the 0, and the 71. I believe that was all of them. And then for the these ones, of course, I didn't put the answers, so I guess we got to do them. So what is the dew point temperature if the dry bulb is 24 and the wet bulb is, actually, I did do these. What am I thinking? I have them right here. So for number 1, hopefully you got 21 degrees. Now number 3 was a little different because they put the wet bulb depression. Now we took notes for wet bulb depression on Friday. If you were in my other classes though, you did take those notes on Thursday. So number 3, when they give you the wet bulb depression, that's how much the wet bulb has been depressed. In other words, it's the actual difference that's listed. So when they said the wet bulb depression is 6, that's the number you point to on the top. So you would have pointed to 6 and, I'm sorry, you would have pointed to 6 as the dry bulb and the wet bulb depression is 1, which should have given you relative humidity of 86. And number 5, you would have picked answer number 2, which was 7 degrees. Are there any that you need me to go over? Number 5. So it says a student used the sling psychrometer to measure the humidity of the air. If the relative humidity was 65 and the dry bulb was 10, what is the wet bulb depression temperature? I guess there's a possibility that I did that one wrong. Maybe. So the dry bulb was 10 and 65. 10 and 65. Yep, I was the wrong one. Because the wet bulb, no, it says what is the wet bulb temperature? I'm sorry. So if I was right. Yep, you did do difference. And they put that answer there on purpose. So they gave you a dry bulb of 10, a relative humidity of 65. That means the difference is 3, but they asked for the wet bulb. So we know the dry bulb was 10, the difference is 3. So 10 minus what gives you 3? So 10 minus 7 gives you 3. That is where the answer of 2 came in. Any other questions? No? All right, so hopefully, I know you guys only did every other as a question in this class. My other classes did all of them. So does anybody here have any questions? You're confident in doing this stuff. So if I gave you a quiz on this stuff, you'd ace it.
Yeah.
Okay, 100%. Good. Hey, by the way, what happens if the relative humidity is 100%? It's raining or snowing or sleeting or hailing. It's precipitating, I guess we should say. What's the dew point if it's raining? Good answer. The same as the temperature. Those are two concepts that you did need to have kind of solidified in your head from Thursday and Friday's work. So I'll repeat them in case anybody missed it. If it's raining or snowing or sleeting or hailing, the relative humidity is 100%, which means the air is all filled up. So when I ask what the dew point is, if it's raining, you know the dew point is the same as the actual air temperature. We are doing that in lab. You might notice the excessive number of sling psychrometers around my room. Everybody will be working with sling psychrometers starting in lab this week. All right, so with those concepts down, let's go back and finish up the page we skipped in the packet. So we're going to page 29 in the packet. And it is a very short reading. And every single time I have a reading in the packet, there are notes on the following page. So you'll see on page 31 is where we're going to be taking notes that go along with page 21. In fact, if it makes your life easier, you are welcome to rip that page 29 out so you don't have to flip back and forth. And I would, in fact, I'm requiring everybody to either grab your own highlighter or come on up and grab one from here. So the highlighters are up here. I will add that to my board for the rest of my classes. If you happen to borrow one of my highlighters and you realize it is dead, please do me a favor and throw it out. Okay, so just like guys, ready to come back? Just like anytime we do a reading, what I want you to do is you're going to be looking for this information in the reading. I want you today to go ahead and read the reading and highlight the answers first. No writing on this page yet. I want to make sure we have all the correct information on this page. So I would hate for you to write something wrong on here and learn it wrong because you wrote it down here wrong. So in the reading, you are looking for a high and low pressure is also known as, I already did the low for you. There are three ways each pressure system, each way the air moves. I would like you to highlight all three. Tell me how they're shown on a map. Tell me the density of the air. By the way, I'm only looking for high or low, not an actual number. The typical weather that you can expect with a high or low pressure. And then we'll draw the arrows together. So the reading is not very long. Would you guys like me to read it or do you got it? I'll read it. All right. So it says, what is a high pressure system? So again, remember, this is the stuff you're looking for. So high pressure system is a whirling mass of cool, dry air that generally brings fair weather and light winds. High or anticyclones have high pressure. The pressure in a high is greatest at its center, and thus winds spiral out of a high pressure center in a clockwise rotation in the northern hemisphere. The air also moves downward. These bring sunny and clear skies. High pressure system is represented as a big blue H. So then what's a low pressure system? A low pressure system is a whirling mass of warm, moist air that generally brings stormy weather with strong winds. Lows or cyclones have low pressure. The pressure in a low is lowest at its center. Therefore, winds spiral into a low pressure system in a counterclockwise rotation in the northern hemisphere. The air also moves up. A low pressure system is represented with a big red H. So again, if you have not highlighted all of that information we are looking for, please do so in the next couple of seconds. Yeah. Oh, okay, it's represented with a big red L. Apparently I cannot read. But I think that your homework was I would have used it on the, no, the sale. You need to do the other ones. So then I'll be able to mix the even numbers. Make sure you know how to do it. All right, do we find all those answers? What did you say a high pressure is also known as? That is an anticyclone. And which way does the air move in a high pressure system? What did it say? It does say it moves downward. That's one. What it did say it moved clockwise. And did you catch the third one? With spirals, which way? Out. Spirals out. So in that list, I don't so much need the spiral part. So if you do just want to say it goes out, clockwise, and down. I do want to stop here for a second because I will tell you, you absolutely need to know these three things. So this is something you have to memorize here. I will tell you, I have never seen them ask anything about an anticyclone. They are fine as long as you know that this is talking about high pressure. Now you do have to remember which way the air moves in a high and a low for that matter. And I have some tricks to help you remember. So we're talking about moving out. So yes, I did talk about this on Thursday and Friday, that wind always blows from what to what pressure? High to low. So that right there is how you know it's blowing out of a high. I also related it to a fart. Some of you didn't like my example, but I'll remind you that farts blow out of a high pressure, your butt, and into a low pressure, the air. So whichever way you want to remember, because you do seem to remember high to low from last year. So that's one thing you can just remember. Wind always blows from high to low. Now the clockwise, I just have a goofy way to remember that. So everybody pay attention to this goofy way of remembering. See that clock up there? See how high it is on the wall? Okay, high pressure because the clock is high on the wall. High pressure, the wind blows clockwise. Here's another goofy way. So I know we're not too low pressure yet, but I'll talk about it. See this counter right here? See how low it is compared to the clock? So the clock is high on the wall, so it blows clockwise. High pressure blows clockwise. The counter is low, so low pressure goes counterclockwise. It's all I got. Well, don't remember that, just as long as you remember. I don't care how you remember it, that's how I remember. And then finally, the going down part. So remember, if I asked you to put pressure on your desk, what would you do? You'd push down. So high pressure is pushing down. Again, like I said, find your own way to memorize it. That's what I do. How did they say they were represented on a map? Big blue H. If you don't have a blue, just label it blue. I don't believe the reading talked about the density, but hopefully you remember what kind of density puts high pressure on something. Is it going to be higher density or lower density? Higher density. Remember, when things are more dense, they sink. When they're less dense, they rise. What weather did it say? It did say sunny. Did it say hot? Couldn't have. No. So we have cool. Yep. So we have cool, dry, and where was cool, dry, sunny, and clear skies. So wait, oh, you're writing. Hang on, don't write that. Again, I have a way of remembering it. I'm not sure exactly why it works, but high pressure. If you remember, high, dry, cool, and clear. High, dry, cool, and clear. I don't know why that has stuck with me since I was in 8th grade. High, dry, cool, and clear. I have a theory of why it stuck. That's because my earth science teacher was literally insane. She was crazy. Real weird. Give you an example of how weirder than me. This teacher of mine borrowed my chapstick. Saw it sitting on my desk and said, "Ooh, Bliss-X, can I have some?" And she took it. Me being the shy 8th grader that I was, didn't stop her, but boy, did I not use that chapstick again. Long story short, she OD'd in school a few years after that, and she's not teaching anymore. So she was definitely out there. So it stuck with me. So maybe it'll stick with you guys. Does anybody remember what I said now? What's the phrase I want you to remember? High, dry, cool, and clear. Okay, make the connection there. My teacher OD'd in school and she made me remember high, dry, cool, and clear. So not going to lie, if somebody was to ask me, "Hey, Mrs. Ritz, what's the pressure outside? Is it a high or low?" In my head, I would recite high, dry, cool, and clear. Then I would look out the window and see if those those technically 3 things are true. So high pressure is always dry. So not raining, snowing, sleeting, hailing, or foggy. I would ask, is it cool? Now by cool, it doesn't necessarily mean it has to be cold, just cooler than a low pressure. And then clear. So guys, why don't you look out the window right now? Is it dry, cool, and clear out there? No. So is it a high pressure out there today? No, today it is snowing. Now I know that cool makes it confusing. That's always the last thing we look at. As long as it's dry and clear, it's going to be a high pressure. Keep in mind, cool is because the air is sinking. So right now it is warmer than if it was a high pressure out there right now. Now, what did they say about the arrows coming? How does the wind blow? How do we draw these arrows? We need to show the out and the clockwise part. To draw this, we need to draw arrows coming out of a high pressure that are curving clockwise. So the way the clock goes. Now, we could get the rest of it from the reading, or we can go and do all of the opposite. We can kind of do a combination of both. Low pressures, as was already written there, they are called cyclones. Again, I have never seen them ask you about that. But they absolutely will ask about the air movement. So as we said, wind always blows from a high to a low. So instead of out, the wind is blowing into a high pressure. Just like I said, the counter is low compared to the clock that is high. So wind will blow counter clockwise, which, by the way, just means the opposite way a clock goes. Hopefully you know which way a clock goes. And because it is low pressure, the air is moving up. And that will be represented on a weather map with an L that is red. Density of the air, since the air is moving up, what is the density? Lower. Now I forgot to put a star here. Nope, not there. Here, typical weather, that is something you absolutely have to memorize for each one. So again, I just remember high, dry, cool, and clear. I know nothing about a low pressure. I do not memorize anything about a low pressure. I just memorize what the high pressure is and think the opposite. So a low pressure, what is the weather? It's not dry. It's wet. So raining, snowing, sleeting, hailing, or very humid. It's not cool. It's going to be warm. And what's the opposite of clear? Cloudy. So today we are sitting in the middle of a low pressure system. And this one, I always struggle drawing my arrows for a low pressure system. We have to show the in and counterclockwise. So you need your arrows pointing towards the L, curving in a direction opposite the way a clock goes. So a clock goes 12, 1, 2, 3. So we need to go backwards. And you can also see that spiraling picture there. I will say you basically, yes, you don't need the names. Yes, you do need the way the air moves. I think how it's shown on a map, the test will be in black and white, so the color doesn't matter. So I think the H and the L are obvious for pressures. The density of the air, you should already have this memorized because high pressure, the air is rising, low pressure, the air is sinking. You do need to memorize which way what the weather will be. And then the arrows, as long as you have memorized which way the wind is blowing, you should be able to recreate the arrows on your own. So nothing here besides the high, dry, cool, and clear, the out, clockwise, and down. Nothing else really needs to be memorized. All right, let's talk about one more thing. So we'll come back to those questions. We already did relative humidity. So we're going to jump ahead to page 36. And we're gonna still continue on things I think you already know. Condensation. It's a fancy word, but I think you already know it. Anybody have any idea how to explain what condensation is? It's like water. What'd you say, TJ? That's actually precipitation is when the clouds can't hold anymore. Oh, the water cycle song. Did you forget it? Did you want me to remind you?
No.
So I'm not sure. TJ, which elementary school did you go to? Arcade. That has been the going theme for the last few years. My arcade kids remember a song. Do Delavan people remember a song? Okay, so here's the good news. I'll teach all of you. It is all TJ's fault. It's all his fault. Are you ready? Okay, are you ready for this? Evaporation. Sounding familiar? Evaporation. There's hand motion. Condensation. Precipitation. Run. Okay, you guys ready? Everybody stand up. No, yeah, it's you. Maybe you like dancing better. Come on, let's make a TikTok. Can we call it a TikTok? Can you all do it?
Oh, yeah.
You can do a whole bunch of goofy dancing on TikTok. But you can't do five goofy dancing. Call the cousin, all right.
Why?
I'm just kidding. I won't make you. But maybe there's extra credit if you actually post it. So as much as that song is goofy, It does give the basics of the water cycle. So which way does air, what's going on with evaporation? Let's start there. Air is going up. Not just air, but water, liquid water, not liquid. Gas, water vapor is going up with evaporation. Then condensation, my hand stayed up and wiggled. What was I representing with the air went up? And then condensation was my hands up here. Clouds. And then when the clouds can't hold any more water, it precipitates. Now I may have added, did you already know the runoff part? That might have been new. That might have been the 10th grade version. So runoff, can you guys figure out what runoff is from that? Evaporation, condensation, precipitation, runoff. What's the runoff part?
Me falling asleep there.
The water.
Yeah, when the water is literally running off the land, whether it's in streams or flooding, that's runoff. Well, condensation's happening up in the clouds. Condensation is at the top of page 36. It is officially the change of phase from water vapor, so gas water, no, right at the very, very top, guys. Right, nope, above the word examples. Condensation is the change of phase from water vapor to liquid water. Now, we already talked about this happening in the clouds, but hopefully you know some other examples. What else in your real life does gas water turn into liquid water? What do you mean in the dishwasher? Okay, ever open a dishwasher either right when it ends or while it's still going? What hits you in the face? Steam. Okay, so that anytime you have hot water and steam is coming off of it, that is the liquid water, especially if you put your hand over that steam, you'll even notice that it does turn to water on your hands. Can you think of some other times you have condensation? Yeah.
Hot shower.
Hot shower, the steam in the bathroom, the steam on the mirror, that is liquid water. Any other examples? A cup of water, unless of course you've gone with a nice vacuum sealed bottle, but if you just have a regular old water bottle or a can of pop, and you have it sitting, it's nice and cold, and it's sitting there on a nice warm day in the summer. We call it sweating usually, the can is sweating. It's not coming out of the can, it's coming out of the air. What else? That's all you guys got? The windows. Hey, right now, if you went up and breathed on the windows, what would happen to the windows today? They'd fog up. Those of you who've ever sat at these black desks and put your hands on those black desks, what happens? You leave a handprint, and how many of you have casually wiped that handprint away, hoping nobody noticed? It is not sweaty hands that are leaving behind the handprint. It's just condensation. It is happening, by the way, on those white desks as well. You just can't see it. What do all these examples of condensation have in common? Cooling down. How's the desk feel to your hands? Cool, especially this black material. It feels cold. How does the window feel compared to your breath? Cold. How does the mirror feel compared to your shower water? Cold. How does the cold pop pan feel to the air? Cold. Oh, another example that we didn't mention was the dew on the grass. The grass should feel colder than the air. Hopefully you know. Okay, so here's an example, if you haven't already written one of the ones we talked about. So I went with the water on the outside of a cold pop can in the summer. You can pick any of the examples we did. Ooh, I did not shake that when I added a liquid IV in it. I think it's terrible.
do you have in there?
It's a strawberry liquid IV, which is basically like Gatorade. Yes, or that, you'll never know. It's not, for the record, I don't like straight liquor. Here's another example. You don't have to put all of them as long as you know. Fog is another example of condensation, but also so is a cloud. How does condensation happen? And then we'll stop after that. Condensation happens anytime warm, wet air hits a cold surface. So whether that warm, wet air is coming from the shower, your breath, your hands, or the actual air on a hot, humid summer day. So anytime warm, wet air hits a cold surface, remember, cold air can't hold as much water, so it automatically turns to a liquid. And on that note, I think that's a perfect place to stop. Your homework will be page 37. If you flip over to page 37. It's either 6 or 8 graphs. I'm not sure off the top of my head. 6, 2, 4, 6. We have looked at graphs. We've actually done a homework assignment very similar to this in chapter 2. I do want you to fill in the sentence. So for example, let's do the first one. Give you only 5 for homework. So it says, as temperature increases, air pressure. Oh, where's my? Well, I don't know where it is on the screen. But as temperature increases, air pressure. What happens as we warm up the air? Does the pressure go up or down? Think about what warm air does. Warm air rises. So if it's rising, do you feel a lot of pressure or less pressure on yourself? If it's rising, less. So as warm air rises, as temperature increases, air pressure is actually going to decrease. And how do you draw first, what goes on the x-axis? Temperature, what you can control. So temperature goes on the x, pressure goes on the y, and what graph would that be? Yep, a down graph. Now I did ask for a reason. Okay, so how can I say that the pressure goes down? So when air warms up, we have less warm air is less dense. That's how you start. Warm air is less dense. And less dense means the air is rising, which equals less pressure. So you have 5 things to do. Each one will be 3 points. You get 1 point for telling me if it increases or decreases. 1 point for completely doing the graph and 1 point for giving me the reason. Tonight's homework is worth 15 points.